Hi, my name is Joanna Misztal-Radecka, and I would like to present our work titled Persona Prototypes for Improving the Qualitative Evaluation of Recommendation Systems. Nowadays, most of the approaches to recommendation systems are designed as black box recommenders, black box algorithms, in particular deep learning approaches, and they are designed by optimizing some accuracy metrics for given data sets. Such an approach may lead to algorithm-driven design of the solution, and it may amplify the hidden data biases and existing disparities, as the results are very difficult to interpret. One of the solutions for this problem is a qualitative evaluation of the results. So the verification of the recommended item lists for particular users. Imagine that we are designing a movie recommendation system, and there may exist different interest groups among our users. For instance, there may be a large science fiction movie fans group, and also a group of people who like drama movies. And there is a small group of users who are interested in musical movies. And there are also some users who don't have any particular interests in this domain. When we perform a qualitative evaluation, we usually randomly select the representative from the dataset. So in this case, if we sample with a uniform distribution, we might select, for instance, two users interested in science fiction and a couple of users from the drama movie fans group, and maybe one outlier. And then we verify what items were recommended for them by our algorithm. The question is if such a method enables selecting good representatives of all users. So do they cover different interest and social groups, and what about the minorities? So note that in such a selection, we wouldn't find any fan of musical movies, as they were a minority and the uniform sampling didn't retrieve any of them. And we wouldn't really know if the system works well for them. So this question is related to the field of interaction design and the concept of personas for the user-centered design of the system. As described by Alan Cooper, as a persona is a precise descriptive model of the user based on behavioral data gathered from many actual users. And instead of using random sample of the dataset, we want to analyze the movies selected for Patricia, who likes old drama movies, and for Scott, who is a fan of science fiction. And they are representatives of the groups of like-minded users. Note that these don't have to be real people. They may be fictional characters, but they need to be good representatives of the dataset and of distinct groups that we want to optimize for. To this end, we draw an analogy between the concept of persona from the interaction design and the technique of dataset prototype selection for finding representatives of the groups of similar instances in the dataset. As a result, we propose the persona prototype approach, which combines these two ideas to select the representatives of user interest groups. In the case of movie recommendations, instead of randomly selecting the representatives, we first note that there exist distinct interest groups, as well as the users who do not have any specific preferences. Next, we select the most representative users from each of the interest groups, who are the core of the cluster. And more formally, we propose this persona prototyping algorithm, which consists of 5 stages that I will discuss in the following slides. First, we construct the user stories for all users in the dataset. The user story is generated by using a generated username, as well as the metadata of the user if available, followed by information about the interactions with particular items in the dataset, and the metadata of items in their history. The next stage is the preparation of user representations in a vectorized format. So we use latent Dirichlet allocation algorithm, which is a topic modeling approach, and it builds user representations in multidimensional topic space in an unsupervised way. An advantage of this approach is the interpretability of the model. So each of the topics, each of the elements in the vector may be explained by the most descriptive words for this topic that have the highest weight for it. So it enables a first analysis of the data set and learning its characteristics. Next, we build clusters of the users, and we use an unsupervised HDB scan algorithm, which and as its characteristics makes it a suitable choice for modeling the user behavior. So it selects the high density regions that may be viewed as the user interest groups, which are separated by the sparse noise points, which are the outliers or the users who don't have any specific interests. Then, one of the advantages of this solution is that the number of clusters is selected automatically, so we don't have to make any assumptions of the distribution of the data set, and the clusters may have arbitrary shape. So it enables analysis of some noisy and non-uniform data sets such as recommendation ones. And then we select the prototypes of each cluster. And these representatives are the most persistent points in each cluster based on the tree built by the HDB scan algorithm. And since these points, these prototypes don't have to be unique for a cluster, there may exist more users who are good prototypes of given group. And then we randomly select one of the users from the group of prototypes for each user segment. And we use UMAP 2D visualization to analyze the spatial relations among the data set. And here are the examples of results for two data sets used in this study. One is article recommendation data set from Desktop, and the other one is a popular movie recommendation, Movie Lens. And finally, we present the personas, and we present the user stories for the personas by selecting the most characteristic elements of their user stories. These are the ones that are closest to the cluster center. And we are currently exploring other possibilities to apply some post hoc explainability models to enable better selection of user story elements. And this evaluation, we first compare the cluster quality measures for proposed method, and we compare it with the baseline k-means algorithm. And we also compare the diversity of selected prototypes. So we want to know if the algorithm enables selecting users of different interests. And we calculate the diversity as an average difference among the vector representations of users. And the results show that HDB scan gives a higher clustering quality for both datasets, Desktop and Movie Lens, compared to the baseline k-means. And the diversity of cluster representatives is also higher for HDB scan compared to the cluster centroids for k-means. And as examples of selected personas, let us introduce Patricia, who is a 30 years old manager, and she watched a couple of movies which may be characterized as old movies, so she's a fan of this type of items. And from this description, we can conclude what is the interest group that Patricia is a representative of. And the other persona for the desktop dataset is Scott. Scott is from United States, and he liked a couple of articles related to Google. So you also know what type of content he's interested in and what may be the other like-minded users. So to summarize, in this study we presented the persona prototyping approach, which is inspired by the concept of persona from interaction design, as well as the dataset prototype selection method. This method is aimed at selecting representatives from dense interest groups, including the minorities. And the approach has the potential to improve the qualitative evaluation of black box recommendation systems. As a future work, we plan to apply this method to evaluate distinct black box recommendation models, as well as work on improving the generation process of user stories, including automatic generation of the descriptions. So thank you. We are looking forward to the discussion, and feel free to ask any questions by email. Thank you.